All right, welcome everybody. Thank you so much for joining today for Understanding the Environmental Impacts of Products Through Life Cycle Assessments. It's presented today by the Steel Tube Institute, and we've got Rebecca Backer here from Parallel. She's the sustainability consultant with the Steel Tube Institute. Really excited for this topic today. Before we jump into the presentation, my colleague Helen is going to give a quick little intro about Acelab. So Helen and I are from Acelab. We're helping out with hosting today's event. Helen's going to show you how to find these folks on Acelab and give you a few quick tips and tricks for using the platform, and then we'll go ahead and get started with today's course. All right, so Helen, whenever you're ready, feel free to take it away. And Rebecca, if you wouldn't mind stopping sharing for a moment, that would be great.
Well, thank you, Bo. Share screen here in a moment. Timely presentation. I know Earth Day was last week. So hi, everyone. I'm Helen. I have my MArch and I'm the Director of Architect Experience here at Acelab. I work with firms like y'all's to talk about ways to kind of strategize and implement Acelab across the firm. One thing that I want to talk about today, and again, timely, is a really fun and I think time-saving option for folks is to build out different projects as well as I call it like, a library of your sustainable alternatives. So this is an option you have in Acelab, and you can invite your whole team in. And what you can do then is something like I'll show you here. This is just a mock-up as kind of an example. But here's kind of a bunch of different sustainable products that we might be looking at, whether it's coatings, decking and pavers, below-grade waterproofing, windows. So that when you're working on a project, you have an easy to access place, with those kind of more sustainable products and seeing if they're, going to work out on your project. So saves everyone some research time, and our team can help you kind of put this together. So this is one use case for Acelab. And then again, we have our project-based collaboration as well as kind of our overall firm library options. And I'm essentially here to help y'all with all of that. So one thing I also like to talk about in these is how we will be following up with you after this webinar. So these folks are going to present today, and then myself and my colleague Evelyn will be creating a conversation for you within the platform. You'll be able to access that by jumping back into Acelab and going to conversations here. Then you'll be able to have a chat. And just so y'all know too, you'll be seeing an email there when we set up that connection, whether it's this webinar or any of the other ones that you attend, outlining product literature, things like that. So you'll get an email. You can also respond to your email. Last thing I'll say is if you are looking to get in touch with these folks, you can type in their name here. Make sure you select brands. And I'll keep typing here. Oops, sorry about that. Just a little refresh sometimes. See who I usually type for. There we go. All right, this will take you to their brand page. You can hit contact here. You'll connect with Dale directly. That'll again start a conversation in your Acelab account. And then scrolling down, you'll get more information about these folks. So really encourage y'all to reach out this way. And I also do free 15-minute calls to again talk about how to make this work best for your firm. So I'll let y'all take it away. Thank you so much.
Awesome. Thank you so much, Helen. We went ahead and launched a quick poll. So if you're interested in connecting with Helen to learn a bit more, feel free to say yes, and she'll reach out to schedule a quick 15-minute demo. All right, without further ado, Dale and Rebecca, I'd love to pass it back over to you to get started with today's presentation.
Hey, awesome. Let me introduce the Steel Tube Institute briefly and help you all understand why this is an important topic to us. So I'm Dale Crawford, the Executive Director of the Steel Tube Institute. I'm here mostly representing our conduit section, or the electrical section. We also have a sizable structural section too. Many of your comments or questions, especially in follow-up, will likely be more so about the structural system, which is great. Just remember that we're also interested in the electrical side of the world, the electrical conduit. What we experience quite often in our market, especially in the electrical world, is the architect and especially the design engineer will use conduit as the basis for design for many buildings and projects. And then oftentimes that is one of the first things that is value engineered out when it gets to the subcontractor level. That is concerning to us because there are many benefits to steel conduit over a different electrical raceway like MC cable or cable tray. And the biggest one that affects sustainability and resiliency is the ability to add additional conductors to it or take conductors out of it. So the use of the building, the electrical use of the building and different loads in the building can change as the need of the building changes. You can't do that with any other raceway without completely tearing out the drywall and oftentimes the studs. So that decision is being made for the building owner and for the architect representing them down the chain without any disclosure to them or any impact. And so that's why we want all of you to know about this. And so we want you to understand, some of the things that we think about within the sustainable world. So again, the Steel Tube Institute is, we are a trade association representing manufacturers. We also do have professional memberships that some of you might be interested in, and we'll have some information about that in our closing comments. But the bulk of the presentation will be given by Rebecca Backer. Do you want to go to the next screen, Rebecca? And so of course, this was when I had, I was skinnier. It was during COVID. I was working out every day, but I still look at that picture and wish I looked like that. But Rebecca is with a group called Parallel. They're a consulting firm in the sustainable space. They're incredible, and they represent the Steel Tube Institute, particularly the conduit section. So Rebecca will be taking the majority of the presenting, and I'll be available at the end to answer any broad-based questions about the markets we represent.
All right, thanks for that, Dale. So yeah, pleasure to meet you all today, or at least to be here and presenting on this topic. It's something that is near and dear to my heart. So as Dale mentioned, I am a project manager with Parallel Sustainability. We primarily focus with helping building product manufacturers develop and implement sustainability programs, whether that's specific to their products or their operations or both. My background is in environmental and sustainable engineering, and I've been in the field now for almost 10 years. And I've had the pleasure of getting to work alongside Dale for the last couple of years as he has worked to champion sustainability, both internally in his member organization at the Steel Tube Institute, as well as with each of the individual member companies that make up the Steel Tube Institute individually. So as Dale mentioned, part of the reason why we're here today is because there's been a lot of talk recently in the market. I mean, it's been coming now for a couple of years, but it seems to be coming to a head on the subject of operational and embodied carbon. Embodied carbon in particular is something that comes into play when you think about the building products that you are selecting to go into your buildings, not just when you're first outfitting a building, but also, as Dale mentioned, when there's tenant turnover. So when you do have to go into a building during tenant turnover and redesign all of those systems, you are essentially increasing the embodied carbon of your building. And once you have the embodied carbon of your building set, there's not really much you can do to reduce it after the fact. So this discussion is definitely something that is going to be a proactive look at embodied carbon, and is going to hopefully help give you all the tools you need to make informed decisions, so that you are selecting products when either you're initially outfitting a building or during that tenant turnover that have done the work in quantifying their environmental impacts, and you're using the tools to select then low carbon products. So that's a bit about what it is, why we're here today. And then a bit more specifically, there is about 5 different learning objectives that we'll be covering during the course of this presentation. So we'll definitely take a step back. I know I just threw a lot of terms at you, from LCAs, EPDs, embodied carbon, operational carbon. So it's always good, though, to start off by kind of remembering, why we're here today, especially in light of the fact that we just had Earth Day and it is the end of Earth Month. So we'll start off by understanding the reason why these tools, specifically life cycle assessments and EPDs, were developed, and how they're used to measure environmental impacts. We'll then review the different elements that govern and attempt to standardize LCAs and EPDs, as well as the process that a building product manufacturer typically follows in pursuing an LCA and EPD. I think this is something that is really important for everyone to understand, especially those who are involved in the building design and construction part of the process, whether that is an initial construction or renovation, just so that they can get a sense of how much time, effort, and data actually goes into these by building product manufacturers or trade associations that are the ones responsible for completing the LCAs and EPDs. So we'll take a brief look at that process and the data that goes into it. And then finally, we'll look at how to read the EPD. So what are the important elements that you should be looking for in the EPD? So if any of you are familiar with EPDs, they can be very long reports. So we'll hopefully help break that down for you all and point out the key features that you should be aware of when you're using an EPD, and also if you're going to be comparing EPDs of similar products. We'll take a look at sort of what is driving this increase in demand of EPDs in the market from both a regulatory and private building standard perspective. And then finally, we'll conclude with a couple of recommendations for where you can find EPDs easily in the market for your building projects. Doesn't want to advance. There we go. Okay. So let's begin by talking about the context in which life cycle assessments and EPDs are important. Unfortunately, as is the case with most things when it comes to sustainability, these two tools were developed to address a specific problem, namely climate change. Life cycle assessments and EPDs, or LCAs and EPD for short, help fulfill the old proverb that you can't manage, or in this case, reduce what you don't measure. So as I'm sure many of you are aware, we are currently dealing with an unprecedented time in history where we are seeing the impacts of industrialization on our environment and climate. Leading experts on climate science and policy have determined that essentially we must keep the Earth's surface from warming no more than 1.5 degrees Celsius, 2 degrees at most, and this is relative to pre-industrial levels, in order to reduce the impact of climate change on human systems, as well as terrestrial, freshwater, and coastal ecosystems. So as the greenhouse gases are emitted to the atmosphere, the greenhouse gases that are emitted to the atmosphere are the ones that are primarily driving this impact on our climate. And what you can see here from this graph, which is from the most recent IPCC report, which is the International Panel on Climate Change. This graph is showing just how much greenhouse gas emissions we'll need to emit or not emit in order to achieve that 1.5 and 2 degrees warming limits as compared to our current trajectory. So this graph is precisely why we are here today. The tools we'll be talking about are tools that manufacturers and industry groups like the Steel Tube Institute and its member companies are using, as well as other players in the industry, to try to get a handle on the greenhouse gas emissions, aka carbon, associated with our buildings and our building products. Breaking it down further, nearly 40% of all global carbon emissions have been determined to come from the built environment, with nearly half of that then coming from building materials that we use to construct and then outfit these buildings. What this essentially tells us is that there is a huge opportunity to reduce global carbon emissions, not only by rethinking how we operate today's buildings, but by also rethinking what we put into them from a building product perspective. So getting a little bit more granular, when we talk about the carbon that is emitted from our built environment, specifically when we're talking about carbon emitted from buildings, we are referring to operational carbon. When we talk about carbon associated with the building materials that go into our buildings, we are referring to embodied carbon. So those two key terms are a key difference to be aware of as we progress through this webinar. Operational carbon is defined by the amount of greenhouse gas emissions that come from operating a building. And from a life cycle perspective, that only occurs during the use phase of a building. Comparatively, embodied carbon measures the amount of greenhouse gases that are emitted during the manufacturing, transportation, installation, use, maintenance, and disposal of the products, which is equivalent to essentially saying the amount of emissions that is produced over the entirety of a product's life cycle. Both embodied carbon and operational carbon can be measured and reported either as straight carbon dioxide emissions, so just CO2, or as carbon dioxide equivalent emissions. The carbon dioxide equivalent emissions is a key term to be aware of when you are talking about and comparing the operational or embodied carbon of building and building products. Because there are other greenhouse gases like nitrous oxide, methane, and various fluorinated gases, which contribute to climate change, in addition to the poster child of carbon dioxide, the industry has basically developed a unit of measure, carbon dioxide equivalent, that represents the collective impact all of these gases, when emitted, will have together on the climate and environment. So the way you calculate carbon dioxide equivalent is essentially by multiplying the amount that each gas is emitted by the gas's potency. So potency is essentially defined as the energy 1 ton of that gas will emit, if emitted, will absorb over a given time period, which is typically about 100 years, relative to the amount of energy absorbed from the emissions of 1 ton of carbon dioxide. So, for example, if we had a process that was producing methane and carbon dioxide, the amount of methane, 1 ton of methane that is produced, would be 20 times more potent than 1 ton of carbon dioxide produced from that same process. Furthermore, as you can see here, the other greenhouse gases like nitrous oxide have significantly higher potencies than carbon dioxide. So even though carbon dioxide is the poster child for greenhouse gas emissions, it is not necessarily always the biggest driver when we look at what is causing climate change. And it's always important to keep the whole picture in mind and consider all greenhouse gases that are being emitted from that process or product. So generally speaking, when we talk about carbon emissions, or carbon footprint, whether it's here in today's webinar or out in the industry, we are generally referring to carbon dioxide equivalent. So even though operational carbon, as you'll recall, only measures the carbon that's emitted during a building's use phase, operational carbon still plays a significant role in a building's overall carbon footprint. With that said, though, because of advances we've seen to energy codes and new building standards that are going beyond code, like LEED, Living Building Challenge, Net Zero, and Passive House, we have developed and seen how current technologies and building design strategies can significantly reduce our building's operational carbon. The graph on the left, which was pulled from a recent study by Sustainable Buildings Canada, shows how, in comparison to a typical code-compliant building, a high-performing building has the potential to reduce its operational carbon by upwards of 75%. For a code-compliant building, operational carbon will generally represent about 80 to 90% of the building's total carbon footprint, with embodied carbon making up the other 10 to 20% of that footprint. In contrast, though, as you can see here, a high-performing building, while the operational carbon still represents the majority of the building's carbon footprint at about 34%, the building's embodied carbon at 34% now is a much higher portion of the product's overall footprint. So even though we've seen a number of strategies and design elements come out that have helped reduce our operational carbon, we haven't seen as many that have focused on reducing the embodied carbon then of that same building. So the amount of embodied carbon has largely remained the same or increased, and therefore has represented a higher percent of the overall building's footprint. And this in turn has driven the demand to understand, aka quantify, the embodied carbon of the products that we put into our buildings. And this is done via life cycle assessments, LCAs, and environmental product declarations, EPDs. So as building product manufacturers continue to quantify the embodied carbon of their products, we are starting to see trends in terms of which product categories generally have higher or lower environmental impacts from a climate change perspective. If you don't have access to EPDs, or you're just starting to get into this kind of world of thinking about embodied carbon from your building's perspective, a good rule of thumb that you can generally follow assumes that interiors like finish and paints will have a lower environmental footprint relative to the structural components like concrete and steel, with facade components like cladding and insulation falling somewhere in between the two. So when you think about which product categories will return the most bang for this work, it's going to be your structural and facade components, where even just a small change, just because of how impactful they are going to have some pretty significant results. So I've mentioned LCA and EPD quite a bit now, but what exactly are they? A life cycle assessment is essentially a model that we build to measure the embodied carbon and other environmental impacts associated with our building services and products. For today's webinar, we'll specifically be looking at how LCAs are used to quantify the environmental impacts of products. The Environmental Product Declaration, or EPD, is then the public report which summarizes the findings from the LCA. So the LCA is the model and the EPD is the public report. Pictured here on the left is a very simplified way of describing what exactly a life cycle assessment model does when we're using it to evaluate the impact of a building product. So essentially what you do is you build a model that represents, for the most part, each life cycle stage of that product. Again, with the life cycles being raw material acquisition, manufacturing, transportation, installation, use and maintenance, and end of life. As we'll get to in a few slides, I say generally, because there are going to be some standards and rules that change which life cycle phases of a product are or are not included in the LCA. You then feed the model a number of data inputs, things like raw material amounts and types, as well as the energy, water, and waste associated with the manufacturing process, as well as emissions, co-products, byproducts, things like that. Also in a few slides, you'll see a bit more of a detailed data request, so you can really see what kind of data we tend to collect when we start in on developing an LCA model for our products. The model then translates all of these inputs through different impact data sets. So that's where you may have heard terms like Tracy or CML or EcoInvent. These are essentially data sets that take these impacts and they translate them into basically different impact categories. So things like climate change, resource depletion, water use, acidification, etc. And then those impacts are then categorized under how they impact human health, resource depletion, and ecosystem quality. And then, as I mentioned previously, All of this is then summarized in some nice graphs and tables and reported in the EPDs that you will use when you're, building and designing your buildings. So an example of some of those graphs is pictured here on the right. So the next part of this webinar is where we'll review the basic concepts and elements that govern LCAs and EPDs to try to ensure that there is some consistency in how we are developing the LCAs and reporting on the results, both overall as an industry as well as by product and by product category. So when we talk about EPDs, there's essentially 4 different EPDs that you should be aware of that are kind of growing in different levels of popularity out in the market. But regardless of which category your EPD falls under, for the most part, all of them are essentially going to be quantifying environmental data in accordance with ISO 14025. And for the most part, these have all also undergone third-party verification, whether that's internal or external. So when those 2 boxes are checked, so ISO 14025 and third-party verification, that's when your EPD becomes what is referred to as a Type 3 eco-label. And that is a term that you may have seen under LEED or other similar green building standards where they are looking for a Type 3 eco-label. That is, again, an EPD that has met 14025 and has passed third-party verification. So within the Type 3 EPD category, there's 4 further subsets of EPDs that you can have. So you have an industry-wide EPD, a product-specific EPD, a factory-specific EPD, and a supplier-specific EPD. With regards to specificity, the most generalized will be your industry average EPD, and then it goes down from there all the way through to supplier specific. So an industry average EPD essentially quantifies the environmental impacts of an overall product or product category using data that's typically gathered from multiple manufacturers. An industry average EPD is typically published by a trade association like the Steel Tube Institute. And so that's what is pictured here on that left corner of the screen. This is the Steel Tubes Institute Industry Average EPD for hollow structural sections. So a lot of STI's member companies contributed their data to this LCA so that you could get a industry benchmark on what an average global warming potential for the products covered in this EPD may look like. From there, growing in specificity, you then have a product-specific EPD. And this EPD reports the environmental impacts for a specific product made by one single manufacturer. If the product, though, is made at multiple facilities, even if it's by one manufacturer, the impacts for that product are typically averaged across all of the facilities that are considered to be in scope. So in the example you'll see here, we have Nucor, which is a member company for STI, and they have published their own EPD so that they can compare how the environmental impacts of their manufacturing for their products compares to the industry EPD that was put out by the Steel Tube Institute. Following a product-specific EPD, the next one in this grouping would be a factory-specific EPD. So this is where the EPD is not only specific to a single product and a single manufacturer, but the results are also disclosed on a per factory basis instead of being averaged across all of the factories. As you'll see towards the end of this webinar, there haven't necessarily been too many factory-specific EPDs unless you've come across a manufacturer who only actually happens to have one facility or one facility where the product is produced. But there is a growing demand for these, and that's being driven primarily by different regulatory initiatives that are coming out of our federal and state governments. And then lastly, the most specific type of EPD that could be published is a supplier-specific EPD. So this is considered probably the most transparent of the four. And this designation would be used when primary data from the manufacturer supply chain is pulled into the LCA. So generally speaking, the data that goes into the LCA is only coming from the manufacturer-owned facilities and operations. But if someone was to work with their suppliers to incorporate their data as well, instead of proxy data, that is where we would see the supplier-specific EPD label applied. To date, though, I am not personally aware of any EPDs that are supplier-specific. It is definitely a newer concept, one that is much harder to achieve, since it does require supplier buy-in. But I wouldn't be surprised if in the next couple of years we do start to see these growing in popularity. So, as I kind of hinted before in defining what a type 3 EPD is, LCAs and EPDs are governed by several different standards and guidelines. So these will include ISO 14025, which I had previously mentioned, as well as ISO 14040 and 14044, as well as the applicable product category rules, or PCR for short. So all of these standards and PCRs are essentially the industry's way of trying to make sure that LCAs are modeled in a consistent manner and that the EPDs are disclosing the results in a consistent manner across product categories and across the industry as a whole. So further defining it, a PCR is basically a set of rules, requirements, and guidelines for developing type 3 EPDs. And as the name implies, is usually specific to a product category like conduit or insulation. As I just mentioned, PCRs ensure that LCA practitioners, so that's the term we use to refer to people who develop the LCA models, generate consistent results for the same product categories. PCRs are generally developed by industry stakeholders, and that group is generally led by a program operator. A program operator is essentially the organization that then does the review and the verification of the LCA and EPD. So just to reiterate, because there are so many terms right now, LCA practitioners are the ones who build the model, the life cycle assessment. Program operators are the ones who verify them and are also the ones who lead the group in developing PCRs and verify the PCRs as well. When you're looking at an EPD, you'll generally see that most of them follow at least 2 PCRs. The Part A PCR is just going to be a generic set of rules that the program operator requires anyone who's coming to them for verification to follow. And then the Part B is where you'll see it become more specific to the product, again, like conduit or insulation. The PCR is also where you will see which life cycles are included in the LCA or EPD. So a lot of the PCRs actually limit the number of life cycles included in the LCA, which we'll get to in a second. But the PCR also dictates how the environmental impacts of the product are disclosed, whether that is on a declared or functional unit. So a declared unit is essentially a physical amount of a product that is used as the basis for the analysis, whereas a functional unit is the quantified performance of that same product. So you won't always see a product category rule having a declared unit and a functional unit. You'll have the one or the other depending on what is most applicable to the product. So I think one of the best examples I've heard of someone trying to explain the difference between a declared unit and a functional unit actually came from someone who used to work at Kohler, where they manufactured things like sinks. So if you were doing an LCA on one of their, say, standard sinks, the declared unit would be just, the weight or the SKU of a specific sink that you're doing the LCA model on. whereas the functional unit would look at the environmental impacts of that same sink over a set period of time. So it might be, what are the environmental impacts of that sink to produce, say, 600 gallons of water during its use phase? So you're getting the physical weight of the product, and then you're also having a performance aspect of it built into the unit. And again, the declared unit or the functional unit is forming the basis upon which the environmental impacts are reported on. So when you're reporting the embodied carbon of a product, it's going to be in kilograms of carbon dioxide equivalent per either pound of product, declared unit, or per the functional unit as defined by the product category rule. So when you're looking at an EPD, of course, because there's not enough terminology and, we like to make things as complicated as possible, you've probably seen where the life cycle stages of a product are translated into this ABCD nomenclature. So this slide here is essentially helping you to break that down and translate each of those categories back to the overarching life cycle stage. So again, that being raw material acquisition, manufacturing and processing, transportation to point of use, installation, use and maintenance, and then end of life disposal. And then again, just to continue to reiterate, it's the PCR that will then tell you which life cycle phases should be modeled in the LCA and therefore have results reported on in the EPD. So when you're looking at an EPD and you see things that start with A1 through A5, that is referred to as the A gate. And the A gate covers manufacturing and installation phases of the product life cycle. More specifically, A1 through A3, which is a common way to report the embodied carbon of a product, includes the extraction of raw materials, that's A1, the transportation of those raw materials to the facility, that is A2, and then the manufacturing of the product itself, that is A3. A4 and then A5 looks at the construction stage, and that includes transportation of the product from point of manufacturing to point of installation, A4. And A5, and it also includes any waste that is produced during the installation process. The B gate covers the use phase of the product's life cycle and includes things like maintenance, repair, replacement, operational energy use, etc. And that's going to be based off of the product and the assumed lifetime of the building. The C gate, that's what covers end of life stages in the product life cycle. So that will include things like deconstruction, demolition, transport to the end of life management site, whether that's landfill or recycling, and then the actual disposal. And then the final gate, the D gate, this is an optional stage where the LC attempts to quantify the benefits and loads that are beyond the system boundary. So that's where things like the product's reuse, the product's recovery, recycling potential, including energy and waste recovery would all come into play. So just from a graphic representation, this is sort of all of your gates, A, B, C, and D, relative to the different life cycles. The vast majority of EPDs that you come across will most likely only be reporting their embodied carbon for A1 through A3. So when an EPD does that, that is referred to as cradle to gate. However, there are going to be instances where the PCR requires the LCA practitioner to look beyond A1 through A3. So when A4 and A5 are included, this is referred to as cradle to use. When the environmental impacts include the B gate and the C gate as well, that is then referred to as cradle to grave. So I keep throwing around this term environmental impacts, but what exactly does an LCA quantify beyond just the carbon footprint of a product? So the carbon footprint, though, certainly is the main reason why a number of different people pursue LCAs and why they ask for EPDs, but it's always important to remember that there are other environmental impacts that are being reported for the product within the EPD. So some of those, when you're looking at the embodied carbon though of a product, again, whether that's A1 through A3 or it's cradle to gate, that's generally going to be categorized as the global warming potential of the product, and it's typically reported in the kilograms of carbon dioxide equivalent. Other impacts that you may see and come across though are ozone depletion potential, acidification potential, and eutrophication potential, as well as resource use and output flows and waste categories. So I won't go into it in too much detail here, but some of the other environmental impacts are generally of interest to people are acidification potential, eutrophication potential, and ozone depletion. Those are probably some of the other common ones that you may come across in addition to the global warming potential of a product. But regardless of what you're interested in looking at from an EPD, all of these impacts are going to be required to be reported in the EPD per ISO and per PCRs. So next, we'll take a really quick look at the process for developing an LCA and publishing an EPD. And like before, I'm going to trick you all into thinking it's a relatively easy thing to do with this very simplified process flow diagram. But generally speaking, these are the different steps that a manufacturer will follow when pursuing an LCA. So they'll start off by working with their LCA practitioner and a program operator to identify the relevant PCR. And if one doesn't exist, they may work with a program operator to get one established. They'll then go through data collection. The LCA practitioner will then do some preliminary prep work and then start building out the LCA model itself. The model is then summarized into a life cycle an LCA background report. This is what is actually submitted to the program operator for verification. And then they'll take the results from the model and develop EPDs accordingly, all of which again is submitted to the program operator for third-party verification. These next two slides are just to give you a taste of like what the data request looks like. When we start working with a manufacturer to pursue a life cycle assessment in EPD, basically the data ask is going to come at them from both a facility perspective and a product perspective. And as you can see here on this slide, as well as with this slide, there is quite a bit of data that gets collected to inform an LCA model. And so when you think about it, all of this is being asked for every product and every facility that is considered in scope. So the lift is already pretty big for manufacturers when you think about what it takes to produce one product specific or even one facility specific EPD. But when you start asking for EPDs that go beyond just one product, you can see how this becomes quite a big effort for manufacturers. And that's the reason I bring this up, is because it's important to remember how much work is going into creating these EPDs with the intent of understanding what the impacts are of their products and then helping to reduce them. So now that you've kind of gotten a taste of what the process is, we're going to take a closer look at an EPD and how to interpret them, and then what things to consider when you're thinking of comparing them. So when you're looking at an EPD, the title page and the cover page is going to contain a lot of the information you're going to want to check for when you're using an EPD. So generally speaking, on these two pages is where you'll see whether or not the EPD is third-party verified by a program operator. They'll typically have a verification stamp on one of these pages. This page will also tell you what the product category rule was that the LCA and EPD followed. And it'll also include things like when the EPD was first issued, knowing that EPDs are valid for at least a 5-year period. The next couple of pages, generally there's a lot of text, some imagery, but those are generally going to describe the different life cycle phases that were included in the LCA model. So you'll see a summary of the manufacturing process, transportation, things like that. The things that will be important to pay attention to is where they report on what the declared or functional unit of the product was. That's generally going to be in its own section, as well as which life cycle stages were included, A1 through A3, and then what other modules. And then the other one that I highly recommend that you take a look at is the assumption section. That's going to tell you what assumptions were used by the LCA practitioner and why. And then the last part of the EPD that you'll most likely be interested in is going to be the life cycle impact assessment results. This is where you'll see the global warming potential as well as the other environmental impacts reported per the declared unit or per the functional unit for the product or products that are included in the EPD. So this table here lists is essentially an incomplete list of where you'll be able to find industry-wide and product-specific EPDs. One of the best databases that we like to recommend people to is the Embodied Carbon in Construction Calculator, or EC3. So this is a free data set of construction products EPDs. And it is also a building impact calculator for those who are involved in the building design and material procurement process. Basically, this tool is an open access database of digitized EPDs that allow users to compare the carbon impacts of similar building materials and assess the impact of the products they have selected on their building's overall embodied carbon. The only criteria for getting your product in here is for it to have a valid EPD. So generally speaking, if a product has an EPD, whether it's industry-wide or product-specific, at some point it's most likely going to make its way into this calculator. We also know that there's a number of program operators who are then connecting their databases to this so that when they verify an EPD, it automatically gets digitized into this tool. So highly recommend you all check this out and play around in it, both from a product EPD comparison perspective, as well as the tool that they have for building designers to select materials and see the impact it has on their building design. Other databases that I'd recommend you all check out include things like Mindful Materials, Ecomedes, and Sustainable Mind. So these are third-party manufacturer agnostic sustainability transparency catalogs, essentially. They're going to list more than just EPDs. So if products have things like a health product declaration or declare label, they'll be listed here. But these platforms are trying to consolidate all products that have at least one sustainability attribute into one place. So building project teams can peruse them and select products that have EPDs and maybe have EPDs plus. And then, of course, I would also recommend you look at a manufacturer's website, or other good resources would be program operators. They'll all list the EPDs that they verify. So in North America, the big players in this space are going to be UL, NSF, ASTM, and SCS Global, and not listed here, but also Sustainable Solutions Corporation, or SSC. So when you go to compare an EPD, I can't stress this enough. As you've seen through the first 40 minutes of this webinar, there is a lot of complexity in developing LCAs and EPDs, and there is a lot that has been established by the industry to make sure things are done in a standard way to help facilitate comparisons. With that said, though, when you're comparing an EPD, please take it with a grain of salt. Before you go to compare the global warming potential from two EPDs of what you think are very similar products, please go back and make sure that you are checking those different elements that we have just called out to make sure it's apples to apples. So look at the PCR that was used and make sure it's the same. Look at the software that was used and make sure it's the same. Some of the leading softwares in the space include Gabi, CIMAPRO. Make sure that the life cycle stages that were included in the LCA were the same. So are they both cradle to gate, cradle to grave? And then of course, look at to see, is it manufacturing specific, product specific, things like that. And what the declared and functional unit were. So again, PCRs and ISOs are trying to take the guesswork out of things, but we're not quite at the point where you can just compare EPDs without doing your own due diligence. So please, please, please make sure you are checking those and making sure that everything is aligned and that it's apples to apples, because even slight deviations in LCA modeling software, whether something's done in Gabi versus CIMAPRO, is going to introduce some level of uncertainty into that comparison. So what is driving now, as I'm sure you've heard quite a bit, that building projects and building product manufacturers are increasing the amount of EPDs and LCAs that are on the market. So this next section is quickly going to take a look at what is driving that demand in the market. So the two on the outside of the government, the big thing that we see driving the demand in LCA and EPDs is basically your green building standards. So things like WELL version 4 and 4.1, as well as the Living Building Challenge. So for anyone who's developing a building or designing a building that is either following these standards or is actually pursuing certification, looking for building products that have EPDs is going to help you achieve points in your pursuit of these certifications. So for LEED v4, there's the Environmental Product Declarations credit, where EPDs come into play, both product specific and industry-wide. And then for Living Building Challenge 4.0, there's a couple of different imperatives where EPDs come into play, including Imperative 7 and Imperative 8. Which looks at the embodied carbon of the overall building and then reducing it. And then also Imperative 11, which is assessing the embodied carbon footprint of your building. And then, of course, as some of you have probably heard rumblings of, there's LEED v5. So LEED v5 is going to be the next big iteration of LEED. We are currently in the public comment period for it. They just released the version 5 standards for all of the different project types, whether that's O&M, operations and maintenance, or the building design and construction designs. And basically, you can expect to see LEED v5 projects being registered as early as January or February of 2025. And the thing to know with LEED v5 is that they are doubling down on decarbonization, so both operational carbon and embodied carbon. Basically, what it's coming down to is that nearly half of the points achievable for any building that is going after LEED v5 is going to be focused on decarbonization. And then the other half will be evenly split between credits that are focused on ecosystem and then quality of life. So when it comes to building products and the EPDs, we're seeing this come into play both as a prerequisite now, where you have to assess the embodied carbon footprint generally of your building as a prerequisite, as listed here. And then also as a credit, where for any building that is specifying products that have a lower embodied carbon as quantified via an EPD and LCA, you'll be able to achieve points and the corresponding credit to this LEED credit. And then quickly, because I want to make sure we have time for questions, the other big drivers that we are seeing in the market is coming from the government. So at the federal level, we're seeing a lot of push for companies and buildings to understand their operational embodied carbon. And that is across the board with new rules that have come out from SEC, as well as from the different programs and initiatives that have been driven by the Inflation Reduction Act. So things we're seeing the EPA start to put together their own programs that require products to have EPDs. And then we're also seeing a lot of Buy Clean task forces come out at the federal level, where you're going to be prioritizing products on government projects that have embodied carbon quantified through EPDs. And then we're seeing a similar thing at the state level. Similar Buy Cleans are coming out in California, Washington, and many other states. So to wrap up really quick, some of the things that the Steel Tube Institute is doing along with its member companies is they are working on quantifying the environmental impacts of their products, both at an industry level and at a manufacturing level. So I can let Dale speak a little bit to that, but I would highly recommend for anyone who's involved in buildings, because structural steel is a huge component of that, as you saw earlier, to follow along with what STI is doing to help quantify those impacts. And then just to wrap up, some things that you can do. I hope that this was helpful in illuminating some of the complexity around LCAs and EPDs, both from a terminology perspective as well as how they're developed, and to prioritize the selection of products that have gone through all of this work, now that you have a sense for it, to pursue an LCA and develop an EPD. Especially if you're going to be following LEED v5 or Living Building Challenge in your design. And then when you are comparing EPDs, to please be careful and make sure you check that it's apples to apples. Okay. And that concludes the webinar. Any questions?
There are 3 in the chat, Rebecca, and we have 3 minutes. So can
Okay.
you, can you do 1 minute per question?
Let's do it and rapid fire them.
All right. Dale, do you want to read them out or you want me to?
Go for it.
Okay, let's start off with this one. Looks easy. Rebecca, thanks for the details. What program is the most widely used to perform the LCA calculations in the industry?
From a modeling software, I would say Gabby or CIMAPRO. They're interchanged a lot. If you're going with UL, they'll be using Gabby. Otherwise, if you're using other LCA practitioners, CIMAPRO.
Okay, awesome. Are you seeing more demand for EPDs of materials in the market, perhaps driven by growing demand of net zero or zero carbon certification of projects?
Yeah, I probably could do a whole webinar on those last couple of slides, so I'm sorry I rushed through it, but absolutely, we are seeing a huge demand for them from the government on their projects, as also in the private sector from architecture and design firms that are pursuing green building standards or using green building standards to inform how they do their product design. So EPDs are the best way to understand the embodied carbon of your building and your building material. So we're seeing a huge increase in manufacturers hearing that signal and pursuing them.
Awesome. All right, and last up, if anyone else has questions, feel free to submit them now so that we have a record of them. You can also place them on the post-event survey. But for now, with the LEED v5 doubling decarbonization, does that replace or supersede net zero or zero carbon building certification? What differentiates both?
Great question. And I'd have to go back and check. I do believe they're going to be keeping their net zero. I don't think I saw it going away anytime soon, but I think what they're doing is they are incorporating a lot of overlap between the two. But again, this is in open comment phase. So I would, anything I say with LEED v5 take with a grain of salt, and we'll see what they finalize after all comments are submitted in May.
Awesome. All right, and looks like we've got one last question of will there be a recording or reference of this presentation we can refer back to? Yes, we will post a recording on Acelab. I'm going to send over a link in the chat momentarily to where you can find all of our past webinar recordings. And I believe Rebecca and Dale also said that they would be happy to share the slides. So feel free to leave a note on the survey if you want to get a copy of those as well.
Yep, and my email address is here too, so please don't hesitate to reach out if you have any other questions on this. I could talk about LCAs and EPDs all day long, as you probably got the gist of.
Awesome.
And likewise, any information you need from the Steel Tube Institute, you can do the post-event survey. I'll take most of the electrical ones, but I have a brilliant engineer that works for me named Holly Schaubert that will take the structural ones and we'll get you the answer.
Awesome. All right. Well, with that, we are at time. So just want to thank everyone in the audience today for attending. We really appreciate you being here and asking so many great questions. If you do have a moment to fill out that post-event survey, that's super helpful for us to hear your feedback as well as be able to answer any other questions that you might have. Thank you so much, Rebecca, for a really amazing presentation. And thank you, Dale, for joining today. I hope everyone has a great rest of their Tuesday.